Hello class, this is Mr. Liao again, and we're looking at section 11.3 rotations. I'm splitting this video into two. The first part is the meatiest part. It's basically going through example 2, so that's the part you really want to focus on because that's going to be where most of the problems are that are going to be on the test. The objectives are to perform rotations, and then in the second video, it'll be performing compositions with rotations and then identifying rotational symmetry. So what's a rotation? A rotation is the transformation in which a figure is turned about a fixed point called the center of rotation. So imagine taking a shape and spinning it around from a central point. That's like a center of a wheel or a tire. Rays drawn from the center of rotation to a point and its image form the angle of rotation. So if you take a look at this diagram here, that means Q has been rotated to Q prime at an angle of 40 degrees. Now the direction of rotation can be clockwise or counterclockwise. In case you don't know which is which, clockwise is the direction the clock goes. Counterclockwise is the opposite direction, except for the clock in front of my room. Unless otherwise noted, all rotations are counterclockwise, so they're going to go in the opposite of the direction of a clock. So keep that in mind, counterclockwise. Now figures can be rotated any number of degrees, anything from 0 degrees to as many degrees as you want. A 360-degree rotation maps a figure onto itself. So if you take a look at this picture, we start at A. So here is 130. That's when A is rotated 130 degrees, again, counterclockwise. Here's the 220, that's A rotated that far, 220 degrees. So that's more than halfway around the circle, halfway around being 180. Finally, we have 310 degrees. So A goes all the way around there. That's 310 degrees to A triple prime. That's almost all the way around. Now, if you go all the way to 360, that's basically going all the way from where you started to where you end up. So this would be 360 degrees, okay? Basically ending where you started. That's 360 degrees. Now you can actually go more than 360. If you go 720, you go around twice. But again, you'd end up where you started. Now there are coordinate rules that you can remember for rotations of 90 degrees, 180 degrees, and 270 degrees. So 90 degrees is basically going 90 degrees counterclockwise, 180 degrees is basically rotating at 180 degrees counterclockwise, and 270 degrees is 270 degrees counterclockwise. Now keep in mind, all rotations are clockwise unless otherwise stated. So 90 degrees clockwise is the same as 270 degrees counterclockwise. Remember, it's 360 degrees all the way around. So here are the rules for rotations about the origin, and that's generally all we're going to worry about in this class are rotations about the origin. So for a 90-degree rotation, we start with point AB. A comma B becomes negative B comma A. Now this year, because of the coronavirus, you will be able to use your open notes to do this, to do a test. So you can have these rules in front of you, but I'll tell you another way to do it in a moment. For a 180-degree rotation, AB becomes negative A comma negative B. And for a 270-degree rotation, in other words, 3/4 of the way around, AB becomes B negative A. So we're starting with example 2A. We have quadrilateral RSTU with vertices R is at 3, 1, S is at 5, 1, T is at 5, -3, and U is at 2, -1. And we're going to graph the original quadrilateral and its image. Remember, the original is called the pre-image. The image is what happens after the transformation. So the image after a 270-degree rotation about the origin. Now again, without a direction, you assume it's counterclockwise. So there is your shape. We're going to spin that thing around the origin, which of course is 0, 0. So we're going to spin that thing around. So here are the rules for a 270-degree rotation. A comma B becomes B comma negative A. So in other words, the X coordinate becomes the Y coordinate but negative. The previous Y coordinate becomes the new X coordinate. So let's apply these rules. So R is at 3, 1. So R prime, using the rule, you flip the coordinates and then you make the new Y coordinate negative. So R prime becomes 1, -3. So it goes right there. S is at 5, 1. S prime, flip the coordinates and then make the y coordinate negative. S prime is 1, negative 5. Do the same with t. T is at 5, negative 3, so t prime is at negative 3, negative 5. Flip the coordinates, make the y coordinate negative. And then finally, u is at 2, negative 1, so u prime is at negative 1, negative 2. Now, if you connect those dots, it looks like that you basically spun that blue quadrilateral around 270 degrees this way. Now, you can also imagine that it goes 90 degrees clockwise, and that's fine too. But remember, all rotations are counterclockwise unless otherwise mentioned. Now, it's nice to have those coordinate rules, and memorizing them will get you the right answer. But that's actually not how I do it, and I would say that's not how most students do it. Now, this year, because the tests will be open notes and open book, you can use the rules and you'll be totally fine. But this is the way that you can do it without memorizing the rules. Now, it's going to be a little harder to do this because you can't see me do this, but just imagine. So here are the 3 steps for rotations of 90, 180, or 270 degrees. Now remember, this is counterclockwise, but if you want to rotate it clockwise, because that's what the problem says, you can just follow the directions, but go clockwise. Step 1 says to graph the figure. So graph the shape as originally described in the question. Then you will rotate the figure the number of degrees stated. So in other words, physically take your paper and rotate it 90 degrees, 180, or 270 degrees. Step 2, write down the new coordinates for each point as if the x-axis is horizontal and the y-axis is vertical. Now, this would be easier if I had paper to show you, but after you rotate it, just imagine that you are now looking at the graph straight up. Write down each coordinate as if the picture that you've rotated is now right side up. So now the horizontal axis is the x-axis, the vertical axis is the y-axis. If it's up, it means the y-axis is the y-coordinate is getting bigger. If it's to the right, the x-axis is getting bigger. So write down the new coordinates for each point. And I'll show you how to do this with example 2a. And then step 3, rotate it back to the original form and then plot the new points that you wrote down from number 2 onto the graph. And that will be the rotated graph. So this is easier to demonstrate rather than explain. So we're going to look at example 2a again, but now we're going to do it the rotating way. So first what we're going to do, and imagine taking your computer or your phone or whatever you're looking at this on and spinning it 270 degrees counterclockwise. Now what I'm going to do is I'm actually going to rotate the paper. I'm not going to rotate the paper. I'm going to rotate the image that you see 270 degrees. So basically I've spun it around 270 degrees. Now what you're going to do is imagine the new coordinates of the shape. So let's pretend that this graph is now right side up. The x-axis is now here. The y-axis is now here. What you're going to do is write down the new coordinates as if the graph were right side up. So here is R. Now using this new graph, you can see that R's coordinates is at 1, negative 3. So that means R prime is at 1, negative 3. If you take a look at point S's new coordinates after the rotation are at 1, negative 5. So that becomes S prime. And you can do the same with T prime and U prime. T is now at negative 3, negative 5, and U prime is at negative 1, negative 2. So what we've done is rotated the paper 270 degrees, pretend that the graph is right side up, and then write down the coordinates as if the graph were right side up. So these are going to be the new coordinates. Now what you're going to do is turn the graph right side up again and plot the points that you just wrote down. So R is at 1, negative 3, S prime is at 1, negative 5, T prime is at negative 3, negative 5, and U prime is at negative 1, negative 2. So this way you can do these problems without remembering what the rules are, and the key is rotating the paper correctly. Let's try another example. Example 2b, graph triangle ABC with the vertices shown and its image after 180 degree rotation about the origin. So 180 degrees doesn't matter if it's clockwise or counterclockwise, you end up in the same place. So there's the original triangle. So we can apply the coordinate rules for a 180 degree rotation. It's a comma b becomes negative a comma negative b. In other words, you keep the same xy coordinates, but you basically flip the sign for each one. So a becomes a 3, 1 becomes negative 3, negative 1. 3, 4 becomes negative 3, negative 4. 1, 1 becomes negative 1, negative 1. And those are the triangle. That's a triangle after you apply the rules. Now let's do it by the rotating method. And we're going to again rotate the paper 180 degrees counterclockwise. There it is. Again, you're going to pretend the graph is right side up. So let's pretend that X is horizontal, Y is vertical. And now we're going to write down the coordinates for each point. So here's point A. You can see where A is. A is at -3, -1. B is at -3, -4. And C is at -1, -1. So those are the three coordinates. Again, you rotate the paper however far you need to rotate it, pretend the graph is right side up, and write the coordinates of each point as if the graph were right side up. Now you turn the graph right side up again and plot the points that you just wrote down, A prime, B prime, and C prime, and there's your rotated triangle. Example 2C, graph triangle JKL with vertices as shown and its image after a 90-degree rotation. So here's the triangle. Now if you want to apply the rule, you can do that. The 90-degree rule is A comma B becomes -B comma A. So you basically flip the coordinates and then flip the sign of the X coordinates. So J prime is 0, -3. K goes from 4, 3 to -3, 4. L goes from 6, 0 to 0, 6. So there's your 90-degree rotated triangle. You can see it's rotated 90 degrees that way. So that's using the rules. Now let's rotate the paper 90 degrees counterclockwise, and we're going to write down the coordinates as if the graph were right side up. So here's your X and the Y coordinate. You notice that J is at 0, 3, so that's where J prime is going to be. K is at -3, 4, so that's where K prime is going to be. L is at 0, 6, so that's where L prime is going to be. Now turn the paper right side up again and plot the 3 points you just wrote down. J prime's at 0, 3, K prime's at -3, 4, L prime's at 0, 6. That ends the first half of the video. This was the meat of the content. In the second video, we'll go over the 2 remaining examples.